Hello and welcome to Network Bytes. In this video, we'll be discussing about ARP, which is Address Resolution Protocol. Even before you try to understand ARP, I would recommend you to go through OSI reference model, and I would recommend you to understand what is the packet flow of flow across different layers of OSI reference model. And along with that, I would recommend you to understand what is IP address and MAC address. For that, we have a video recorded. I'll be sharing the video link in the description box. If you are not aware of the things that I have just mentioned, please go through that video and then come back to this video. Now let's jump into this video. So ARP is Address Resolution Protocol. As the name says, ARP resolves MAC address associated with a particular IP address. Now let's try to see how exactly it does. Now you can see there are two devices on my screen. So there is PC4 and there is PC5. Now let's see what are the details of it. PC4 has details like IP address and MAC address. IP address of PC4 is 192.168.10.10. MAC address is 0090.0cb9.9903. In the same way, PC5, which has IP address of 192.168.10.20 and which has MAC address 000A41A62770. Now, let's try to do a ping from PC4 to PC5, which is nothing but PC5 to 192.168.10.20. Now, let me do that from the command prompt. Don't worry if you cannot see the command prompt, it might be hidden. I'm just uh, typing a ping command, ping 192.168.10.20, and I'm just hitting enter. Now you can see as soon as I have hit the enter for ping, I can see there is a ARP table ARP packet initiated. Now let's try to decode that packet. So initially what ARP does is it will send a ARP request to find out MAC address associated with a particular IP address. What is that particular IP address here? IP address of PC5. Here you can see, right? This PC5, whose IP address is 192.168.10.20. So now you can see here, you can see the details here. So let's try to decode this ARP packet. So there are details like ARP code. So it being a ARP request, it has a ARP code of 0x0001. So whenever you see this ARP code in any ARP packet, that means it's a request. It's not a response reply. So reply comes from the destination. Now we being the source, that is PC4 being the source, and it initiated the packet. So it has a request requesting for MAC address of 192.168.10.20. Now it knows it knows IP address of destination, but it doesn't know what is MAC address of destination. So it just puts 12 zeros there. 0000.0000.0000. That means unknown. I don't know that. So it's PC4's way of saying that I don't know MAC address of it. Please find out. It's more than anything. It's a query. It's just asking what is the MAC address of particular IP address. Now, other details when you see, it has source MAC, which is nothing but PC4's MAC. It has source IP, which is PC4 source IP. And these are the details well known to PC4. So it just has put those details there, and now it will send the packet to switch because that is the communication medium here. Now switch has details like inbound packet and outbound packet. Here inbound packet is nothing but PDU, packet datagram unit, which is nothing but the packet that is coming from PC4. Outbound is something which has to go out of switch. It may be PC5 or any other devices that are connected on the net switch. Okay. Now let's try to understand what are the inbound packet details. So inbound packet is coming from PC4. So source IP is 192.168.10.10 and source MAC is 0090, which is MAC address of PC4, and destination is PC5's details that you can see here. Still it is a request, so its ARP code is 0x0001, and along with that protocol type is 0x0800, which is for ARP. Okay. Now let's try to see what is going out of switch now, right? So let's see. What is going out of the switch? The same packet again. It knows what is the source. and it knows what is a MAC IP address, but it doesn't what is a destination IP address, but it doesn't know what is destination MAC address. So it has necessary details. It has source MAC, it has source IP, it has destination IP, but it doesn't have destination MAC because it doesn't know. So outbound packet on the switch is similar to outbound packet of PC4. Now let's see what happens next. Now I'm just taking that packet forward. Now I can see the packet has arrived at PC4. Now on the PC4, when the packet has arrived, it has two details again. What is inbound packet details? There are two details. What is one of them is inbound and one of them is outbound. So when you see in inbound will have the same details as that of the packet which is coming from switch, right? Outbound will be different. Now let's try to decode this. Now inbound PC PDU details are similar. Like it has PC4's MAC address, PC4's IP address, and destination as PC5's IP address, but it doesn't know PC5's MAC address. That is inbound, which is coming from switch 1 to PC5. Now, what PC5 has to send to switch 1? Now again, so far it was request because it is coming from switch. It was a request, so it is still a request. Now let's see what is outbound. Outbound is a response here because outbound is something going from PC5 to switch 1. That is a reply. That is a response to this packet. Okay, that for this ARP request. Okay. Now let's see what it looks like. Now when you see it here, you can see ARP code has changed to 0x000002, which is nothing but reply, ARP reply. Okay. And if you see source MAC, it has changed here. In inbound, it has MAC of PC4, but in outbound of PC5, you have MAC address of PC5 because it is now this is a source. PC5 is the source, and it is sending out the necessary details to PC4 via switch one, right? So now you have source MAC, which is PC5's MAC, source IP, which is PC5's IP, and target MAC. You are aware because you know PC4's MAC that the details are uh, those details are gained from the ARP request packet. Okay. So from ARP request packet, it knows which MAC is requesting for my MAC, that is PC5's MAC. So now it is just sending its details in the source information. Then it is sending what is the target IP here? PC4's target IP, which is nothing but 192.168.10.10, right? So I hope so far it's clear. Now let's try to move it forward. Now it is sending a reply. This is again ARP reply now. ARP reply. It's an inbound packet for switch one, where we have ARP code as 0x0002, which is ARP reply, and we have source MAC as PC5's MAC, and source IP as PC5's IP, target MAC as PC4's MAC, target IP as PC4's IP. Okay, because it now it being a reply, it is sent from destination to source. That is nothing but PC5 to PC4. So the source and destinations will be changed here. Now, what is outbound here? 000A, 41A6, and 22770, which is nothing but PC5's MAC, and 192.168.10.20, which is nothing but PC5's IP, and so target details will be PC4 details, as we already know. Now let's try to move it further ahead. Now, when this packet has received, it is marked as complete because now there will be a ARP table created with the details so far it has collected. Okay. Now what is inbound details? You can see it here. It is coming from PC5, which is MAC, which is having this particular MAC, which is having this particular IP, and received by this particular device, which has MAC address 00900CB9 and that, and it has a MAC address 192 IP address 192.168.10.10. That means the whole process it goes through two things: ARP request and ARP reply. So ARP request is initiated by the source whenever it wants to figure out IP address of a MAC address of a particular IP address. Now again, if you have observed closely, now let me walk through from the beginning. So here it has initiated the packet. So along with the ARP table, so it is the first packet in our whole flow. What happened initially? PC4 has initiated a request with PC5. So it has requested for MAC address of PC5, which has a IP address of 192.168.10.20, and the details that are well known to you. So now, because you have just gone through that process so far, source MAC is MAC address of PC4, source IP is IP address of PC4, target MAC it doesn't know because it doesn't know what is a MAC address. That's what ARP has to find out. That's why it has all zeros. And target IP 192.168.10.20, which is PC5's IP here. Along with that, you must have observed one more thing here: destination address in the Ethernet packet. It is source IP is source MAC is specified here, MAC, because Ethernet frames deals with MAC addresses because they are layer 2. So here you can see source MAC address is of PC4. Destination address is multicast MAC address because it doesn't know what is the destination MAC address so far. Now in the next packet, what happened? Now let me go to this. What is received from by the switch? In the switch also we have the same thing because so far we don't know any details. So that will be having very much same details as what PC4 has sent. Now let's go what happened is PC5. PC5 receives the same thing here and the target MAC, but what PC5 sends back to switch one is here. You can see destination address is PC4 destination MAC address and source MAC address is PC5's MAC address. That means now it is no more a multicast. Now it is just sending to particular devices. Now it knows what is the destination that it has to deal with. So there it has. We already have discussed this ARP. So it has source IP source MAC of PC5, source IP of PC5, target MAC of PC4, target IP of PC4. So in the same way, it will reach to switch one, then switch one to PC4. Then further, when you want further communication to happen, it won't perform any ARP again because it already has created a ARP table. Now next time it just sends ICMP packets because I did a ping ICMP request, then it will go to PC5, then PC5 will send a ICMP response, and that means one whole communication, one whole circle has been completed. Like that, how many times, how many packets it want to receive from the destination, it will ICMP packets it want to receive from the destination, that will be received by PC4. So this is how ARP works. ARP works in a way it tries to find out or it tries to resolve MAC address of the IP address. And what are the challenges involved here? The major challenge involved here is any person who is sitting in between. For example, right now there are only two people in the network, but let's say there is third person. There are chances that this third person who is sitting, who may sit in between these two devices and portray his MAC address is, I mean, whenever PC4 requests for PC5's MAC address, he'll portray himself as PC5 and he can just spoof to these two devices, which in turn is called as ARP spoofing. That means a third person, man in the middle, is trying to replicate. For example, a PC4 is trying to communicate to PC5, PC6 act as a PC5. When PC5 wants to communicate to PC4, PC6 act as PC4. So it just makes sure, PC6 makes sure it is just dealing with PC4 and it is just dealing with PC5. Thus, it is entering into a private conversation. That means it is more it is more than anything, it's an attack on the ARP. So to avoid that, there are ways that ARP table will be static. I mean, in most of the network they will mark it as a static ARP table to avoid any dynamic configurations. That means every time when ARP table is reset, they don't want to start whole process of ARP request and ARP reply, thus uh, landing into a place where a third person will listen to them. So to avoid all that stuff, there is a solution which is static ARP table. So they will configure a static ARP table so that PC4 will have very much details of PC5 and just communicate straightforward. It doesn't want to go through that whole process, ARP request and ARP response. So I mean, there are challenges and there are solutions for that. So this is all about ARP and ARP spoofing and how it works. And this is basic ARP. And ARP is not only useful for finding out MAC address from IP address, but It does other way also, that we call as reverse RP. So far we have dealt with only layer 2. That means this is all a single broadcast domain. But when the broadcast domain changes, what happens when there is a third person, when there is a layer 3 device that comes into picture, and the device to which PC4 wants to communicate is staying in a different network altogether? What happens in that case? So for that, we have something called proxy ARP, right? So that is called as proxy ARP. That means, so when the communication happens from PC4 to PC7, this router will act as a proxy for PC, this network switch 1 and this network switch 2. I mean, it segregates these two networks, and it acts as a proxy between these two networks. And for PC4, the destination is this interface, and for PC7, the destination will be this interface. That means the whole communication is broken into two channels, two communication channels now, right? Single communication channel has been broken into two communication channel where router is acting as a proxy. So that part of ARP is called as proxy ARP. And there is fourth type of ARP, that is gracious ARP. So gracious ARP is something which is helpful to find out if there are any duplicate IPs present in the network. Along with that, there are many other places where gracious ARP is useful. As this particular video is more about ARP, I'll stop this video here, and we'll be discussing about gracious ARP, proxy ARP, and reverse ARP in further videos. Thank you for listening to the channel. Please subscribe to the channel, like the video. Thank you.